All right. Good morning, everyone. Let's get going with today's class. So before we jump into our next exercise, I just want to follow up with you about both the assignment and last class quiz, just so we kind of go through that and make sure everyone understand what's going on. And if you got this right, I think most of you did get it right. That's awesome. And if it did not, I just want to walk you through what I was expecting, right? So in class, going first on the data wrangling assignment, in class we went through and we wrangled this data set that could basically be summarized by simply running, just close these, simply running the pipe workflow that we created, right? So if you were successful in copying and pasting each one of the functions here, adding the pipe, removing the data set, this should have worked for you, and you should have been able to reproduce soy K in the end, right? Now, on the assignment, I left you there at the beginning of the code, and really, if you read through what I was asking here, so I wanted you to do this in a pipe workflow to generate the potassium concentration percent for each potassium rate within each location. So we had 4 locations, we had 4 potassium rates. So I was looking for 16 values, right? And when I say here, basically averaging over reps, I mean that you're taking the average. So if you have 3 reps with 3 values, you're basically taking the average of those 3 values, right? That's what we're averaging over. And I think by saying this here, I may have unintentionally confused some of you. And I'll tell you here in a second why that was. So really, everything you had to do was just come back to the pipe workflow that we did. You just copy that first pipe there all the way to the end. You just pasted that here. And then there was one small change here that we needed to do. Or maybe, well, I guess this pipe here doesn't end here. We still need to add the group by and the summarize, so which is not in this pipe workflow. So let me just come back here and get that group by and summarize as we had in class. So this is the code for the assignment. So I just paste it here. So as if you remember on the pipe workflow, you don't have to specify the data coming in. So we would have just deleted that, added another pipe, and then do the summarize. So if you went back to that chunk where we had the summarize, this was the code. I'm just copying that and pasting here. And again, just deleting that data set name because we're using pipes now. So if you run this is what we would have gotten from the exercise in class. So we're basically taking the average KPCT for each location. However, the assignment was asking for us to do that for each combination of location and potassium rates, right? So there's one little thing in this whole code here that we have to change for that to happen. And I know, a good number of you got this right. So what did you change in this code to get to the answer of the assignment? Send us.
Group by.
Okay, so group by, what did you change here?
Group by any comma and potassium grade case for it.
Yes, that's exactly right. So this is the only difference on the assignment from what we did in class. It's just that we're creating groups that include both the location levels and the potassium rate levels. So if we run this, you do get your 16 rows, you do get your location column, your potassium rate column, and your mean percent for each one of those combinations of location and potassium rate. So this is what I was expecting for you to send over. A lot of you did this. Some of you did the following. Instead of putting group by location and rep and potassium rate, you group by location and rep. And you send me this, which is unfortunately not the answer I was looking for. The values are not the correct values because now you're looking in each one of the blocks, so you're averaging over the treatments actually and just getting the block information, which, you know, it is a valid query, but it's not what I was asking for. So if you did this, you lost some points, still got some points, but you lost other points. So the correct answer would be group by location and potassium rate, and then getting the mean. So this exercise, you know, it's just, I bring this in because it is a, you know, you're going to be doing a lot of data processing in this course, and I'm sure in your research as well. And this is just exposing you to some of those concepts. And so I do want you to think through and understand what we're doing, you know, so we can apply this to your research later. But this is just one example of, as you can see, is a very small difference from what we did in class. And this is what that would have been. Any questions about this?
Uh,
Oh, yes, go ahead,
a lot
Ramon.
of questions. Yeah, so I'm very I did all those steps, but I guess at some point I have to share with you what initially I was not running the file that I was supposed to, and then I did this except for the K rate, kilograms hectare, but I didn't get to that point. I only got one column,
Yeah,
and I went back and review, and I end up get to that.
yeah, I think, I mean, we can connect later, like individually, and I can kind of check your code and see what happened. But really, like, you know, if you look at the code that we developed in class, the only difference is just that we're adding this here. So everything else. So if you got just one column, my guess is that you probably have some issues on pivot longer. This may be
Mhm.
where your issue happens. So take a look at this function specifically, compare our class code with what you're doing on your side, and see if you find any differences here. But I think it could be there. Yeah, and also
Yeah.
something that, yep, somebody else had a comment?
Yes, I was gonna ask, I've tried rerunning and looking at my difference, and I know, so like I had emailed you and you said that it was probably in an error that I had prior. I had gone back and fixed that error, however, it's still not running right, not working for me.
Yeah, so why don't we do this? After class today, let's get into, like, I mean, if you all have time, let's get into a Zoom call, Rolando, and is that Clint?
That's Clint, yes, sir.
So Clint and Rolando, let's get into a call and double check what's going on, so we kind of understand what's going on and go from there.
Thanks.
All right, yes, sir.
Thanks, guys. All right, so this is what you needed to submit for your assignment. I do want to give you a tip here that's going to be really important for you, because from this point on, we're going to be using pipes a lot. And I'm sure you're going to run into issues when you're coding on your side. So if I have a problem anywhere here, so let's say I forget to add this comment. So a very small, silly problem. If I run this, it's going to give me an error, right? So the error, it may be helpful. So here's kind of telling you where something is going wrong, right? Even though it's not saying specifically there is a comma missing right here, but it kind of points you in that direction. And if you look and compare, sometimes you can find the error. Now on a pipe workflow, because you have so many functions, sometimes it's not very clear where the error is happening. So one tip to give you, and this is really important that you understand this, because it's going to help you with all the pipe workflows we're going to be doing from this point on, is, so let's say I run this and I get an issue, right? The first thing I can try is to run only the first line and see if the error happens there. To do that, I just basically come right just prior to that pipe, add a hashtag, and then run that. So that hashtag comments off that pipe. So it stops the code from running after that point. And you can run this and just see what's happening at this level. So if I run this, it printed, so okay, so that's not where there is happening. So I come here, uncomment that pipe, let it go through, but then comment the next one, and then run this code. Okay, it worked well, it did what it was supposed to do, so it's not here. So just keep going that way. So I'm gonna do the next one for the mutate, so let it go through the mutate, but then stop right there. It's working. Then finally, I let it go through where I know where the error is because I created the error myself. So it is here, right? So if I run this and I get an error, okay, so I know it is in this mutate here because everything else above ran okay, and I'm stuck here. So this is where the error is. That's one of the ways that I use when I'm troubleshooting code, especially in a pipe workflow. So this can be a very useful approach for you as well. All right, so this, the assignment, I was grading it this morning. I will publish your grades for this, hopefully today. I do want to show you here now the quiz for last class. So just to let you know, the quiz for last class, it was more of like, are you, even if you got it right, if you got it wrong, it doesn't matter. Yeah, I just wanted to see if you were thinking about these layers. And I just wanted to get that. So really, you all got all points for the quiz from last class, but I do want to just open here because some of you got everything right. Some of you missed maybe one or two of the layers. So I just want to get to that and just show you what's going on here. Some of you were really spot on. So what is going on here is we have a raster layer, which is the NDRE. And you do see that, if we just zoom in here, you do see there's these empty spaces, which some of you thought that this raster layer was actually a point layer. And it is not. And what's going on here is that all of these missing pixel values are because they were classified as soil, and I removed those on purpose because I did not want to have soil pixels when I take the average NDRE of a plot. So you see the alleyways were all removed. There was a road on top. Of course, you don't know this, but I'm just giving you more context. There was a road on top that was removed. All the alleyways were removed, and any pixels in the plots that were classified as soil were also removed. So the green red layer here, it is raster, meaning that it is cells. So it has cells everywhere in this image here. So if you think of starting up here all the way to the bottom here, these are all pixels. The difference is that some of them were removed and were set to NA, so not available. And that's why they just show white. But this is the raster is a continuous layer that even if you don't have a number there, like an NDRE number, you still have a cell that is just coded as NA in this case. On the contrary, we also have a few vector layers here. So the plot boundary that you see, the black line, is a vector polygon. And we use that to create a negative buffer that you see inside that is also a polygon. So it's also a vector. And then we get the mean of the pixel values within that negative buffer. So we're just removing the outer rows here. That's common in research. So really, we had three layers here. So one was a raster that was this NDRE image, and that was a drone image. And then we have a vector plot polygon, and then a vector plot negative buffer there. Some of you got it all, but for those of you that did not, don't worry, you still got 100 points. I just wanted more to see how you were thinking about these. And, again, here a difference, just to point out again, and we're going to see this more in future classes, is a raster is always a continuous layer. You don't have holes in that raster layer. What happens is you may have cells that are NA. The cell is still there. And you can see if I just zoom in here, there's still a cell here. It's just that cell is set to NA. So it's not like that cell does not exist. It is there, it's just NA, which is different from vector, right? So a polygon, this is polygon, vectors are not in a grid format, so they're not pixels or cells. They're just like this feature, right? So this boundary is a feature. And then you don't have to have vector layers that are continuous within the whole scope. So you see there's no plot boundaries here, right? So that is one of the points, I guess, of the difference between a raster and a vector. Any questions or thoughts about this distinction here? Yeah. So why I have two boundaries, like the black one and the inner one? So this is a field research area where our goal was to assess crop vigor related to nitrogen, and then use that information to create a recommendation, like a nitrogen rate recommendation. And these are 4-row plots. And normally we avoid the outer rows, so row number 1 and 4, we don't collect data from it because they suffer from the boundary effect, right? So let's say if, let me use my cursor so people can see. So let's say right here is a good example. So I just from the NDRE data, I'm assuming this is a 0 nitrogen treatment because it's lower NDRE. And it may be next to like a full rate nitrogen treatment. So that those two, so the last row of the 0 and the first row of the full rate are neighboring. So there is a chance that maybe the treatment that you applied on the full rate may affect the first row of the 0. So that's the boundary effect that we want to avoid. So by doing a negative buffer that takes into account the row spacing, I'm basically ignoring the outer 2 rows. And then only extracting the mean NDRE pixel value from this shaded area instead of for the whole plot. All right, any other thoughts or questions about these? Okay, I don't hear anything, so let's keep moving. So today I want to, so I hope that you were all able to follow last recording. I was not here in person. I was attending a conference in Tifton. But I think it was pretty straightforward. I hope that you were all able to download the NASS data, specifically with the selections we made. That's going to be important because we're going to be using that data today. So my goal with this next exercise is to expose you to a little bit more of data wrangling. Again, this is something you're going to do for every single project, and you will need those skills. However, now we're using a data set that can be within a geospatial context, which is data at the county level. Even though today we're not going to be seeing that in the spatial context, but we will apply a spatial context to this data set on Friday. So I do want to bring this new data set that has a spatial context, so you become more familiar with both data wrangling, but also geospatial data in R, before we do get into the field level precision ag analysis that we're going to be start doing with the monitor data cleaning. All right, so for today, so if you did download the data from last class and you were following those last instructions in that slide, you would have already downloaded that data. We're not going to go through that again since that's something that was done on the previous class. I'm coming here on my class main folder, and we're going to set things up today. So I do want to ask you that, so I guess on the recording, if you did follow the last instructions or the instructions on the last slide, I was asking you to create a 02 NASS folder. Actually, for this semester, we're changing that name to a 03 since I started some of our projects here a little bit earlier this year. So instead of a 02 NASS, I want to ask you to first go to this class main folder in your computer, create a 03 NASS folder in there. Go inside of it. I had just already moved that data set in here, just so I knew it was here. But as you know, you would come here, create a new folder for data, a new folder for code, and a new folder for output. So we're just setting up our environment for this project. We're always going to be following this, so do get familiarized with how to do this. Once you create all of your 3 subfolders, we're going to move that soybeans_nass.csv into the data folder. Right, so I just did that. So now my soybeans_nass is under my data folder, which is under that 03 NASS project or folder at the level of the course. Okay, so we set up our folders. The next thing we're going to be doing is creating a project. So you can just go ahead, if you don't have any RStudio window open, you can just open a new one on your computer. If you do have from a previous project that you were working with, that's okay, you can open on that one. The main goal is that you have RStudio open, and then click on that right-hand side where we create projects. So click on there. We're going to say new project. And because we already created the directory, it's going to be an existing directory. You're going to browse to that 03 NASS folder that we just created. So make sure you go into that folder. Make sure you're seeing that the contents of that folder. So you should be seeing this. You should be seeing code, data, and output. If you're inside of code or data or output, you're in the wrong place. You need to go one level up. So when you are at this level, you just click open. And you can select this here for open a new session. So you keep your current RStudio window, but then you do open this or create this project as a new RStudio environment. So this should launch, a new RStudio window. You know you're in the right place because it says on the top 03 NASS. If you look here on your right-hand side under files, if you're not at the main level, you can click on that R blue button and check that you're here. You should be seeing 03nas.rproj, code, data, and output. And the only thing that you may already have in this is your data that you downloaded from last time. Yes, we have a question online. Nope.
So, we need to open it up on the NAS folder, is that what you're saying?
Yeah, so when you were creating the RStudio project,
Yes.
you wanna browse to that 03 NAS folder and create at that level. Okay, I just want to take a very quick moment here and check if everyone was able to do this. If not, please let me know. This is an important step for us to all be on the same page.
It's not letting me create.
What is it saying something or?
It's not saying anything.
I got an error.
Oh, I think it's because you said create, well, sorry. Can you go back there on that button, let's just see. Can you just cancel, just so I can see, like, just click on that project none, and then new project, is that the one that showed us? Okay, so you wanna come on, yeah, you wanna come on existing directory, and then we're also that way. And that should work, yeah. Yeah, that's let me go to the folder so you can hear. So just a quick tip here. So when you're creating a new project, so I can show you how I would do if I were doing a new one here. Click new project, and then it gives you this prompt here where it says new directory, existing directory, or version control. We're normally, at least in this class, we're normally going to be using existing directory because we have already created that directory. If you had not created yet the 03 NAS on your computer folder system, then that's when you would use new directory because you are creating that directory. But in our case, we're most of the time going to be using the existing directory option. So just wanted to point that out. Anyone online need help? All right, I don't hear anything, so I'm going to assume you're all good. Okay, so normally I don't really, if you come here on the Files tab, you're not going to really be able to move things in or out or copy and paste like you would if you are in your computer folder system. So when I want to do that, I just go to this folder in my computer, right? So in my case, it is right here. So I just come to it. If you have not done that yet, I want to ask you to first move that soybeans_nas.csv dataset that you downloaded last class. Move that inside of the data folder. Right, so it is a data set, it goes into the data folder. And the next step for the script, I just uploaded earlier this morning a script that we're going to be working today to GitHub. So as you know, if you're just manually downloading like we've been doing, you would go on that GitHub repo. You click on the code green button, download zip. You can move this zip inside of the course main folder. So I have that right here. Mine doesn't say main, but yours probably does. So when you unzip that, you just want to go inside of 2024_PPA. You go inside of class code, 04 class code, and there's going to be this 0124 NASS summary partial script. I want you to copy this script. Go back to the folder main course, go inside 03 NASS, and paste that script under code. So for you to be ready for today's exercise, you should have created the 03 NASS folder. Inside of that, you should have created code, data, and output. Should have created our project in our studio, and you know that was successful because you would see that 03nas.rproj icon in your folder. You should have moved the data you downloaded from NASS to the data folder, so the soybeans_nas.csv. And you should have downloaded the code from GitHub and copied that and pasted inside of the code folder. So you would have this setup. I want to give a quick moment here because if you're still doing it, we're going to wait until we all can finish this. If you're having issues with finding things and you weren't able to follow the process, let me know. Anyone still need some time to finish? If you do, please tell me. If not, I'm gonna keep moving. Rolando, how are you doing?
I am trying to, I just copy the, because it's the PPA main download is a PPA main 7 for me. So I just copied it and put it on code.
Okay. Yeah, it's probably because you downloaded the same folder before, so it's just like creating new copies, and that's okay. I mean, you can delete the previous ones if you want, because again, we are not doing our own coding inside of that folder. We're just copying that and moving that to your folder. Yeah, so just make sure you copy that script inside of the code folder there.
Yeah.
All right, so let's well, are you, Sandesh, are you doing okay? Sorry, did you say yes or no?
Yeah.
Okay. All right. Okay, so let's move on here. As a refresher for you, remember that every time we're working with projects, we want to make sure we are in the correct RStudio window, right? So in my case here, that would be this one, where you would see the 03 NASS name as the project name. If you're not seeing 03 NASS, close that window that you are in right now. Go back to your files in your computer and launch that 03 NAS rproj icon. So you are in the right place. Okay, so once we have everything set up and we are in the right place, we want to come here on the Files tab. If you're not seeing the main folder of this project, click on the R blue button. We want to go inside of code and launch this code from here. So if you just click on it, it should pop up on the left side. Okay, so a very quick note here. So notice how now this is a different file extension. It's a .qmd. This is because this is a Quarto file. If you know, in your case, for you all, I already introduced you to R Markdown first. And R Markdown and Quarto are very similar. So if you worked with R Markdown before, Quarto is going to be very similar to that. So you have the YAML. In this case here on the YAML, I have already changed some things. We're not going to really get into the details of what they are, why I changed them. If you do get interested in playing more with Quarto and customizing it, then you can look for some resources on YAML, and you can ask me if you wish. I can help you as well. But this is just to let you know that it is a different file type, so it is a .qmd. But as far as we're concerned, it's going to be very similar to our Markdown. I am showing you this because this is probably the most modern script type. So Quarto has been a script type that has been introduced more recently, and it works well with Python, Julia, observable JavaScript, and some other languages. So if you are working in other languages and you wish to have the the power, I guess, of our Markdown in other languages, Quarto allows you for that. If you're not using other languages, you don't really have to worry much about it, but I just want to introduce that to you. Okay, so our goal with this script here is to explore that NASS data set. So if you recall, we downloaded soybeans production over the last, I don't know, 40 years or something like that, for every county in Georgia that reported soybeans production, right? So if you've never used the NASS quick stats portal like we did, that's a really, really useful source of data for this type of data. So especially if you want like county level, state level, even like country level data on really any crop. If you get more interested in explore that tool, there's really so much data behind that tool that you can retrieve for all different crops, all different crop statistics. It's really nice. So especially if you're in grad school, we're writing a report saying, Georgia is the most important producer of X crop with X area planted and yield of Y and production of W. This is where you would get the reliable source of that type of data, right? So this is the official United States Department of Ag portal for ag-related statistics in the US. In our case here, we downloaded data for soybeans production at the county level for all the years that were available. And now we're going to bring in this data, look at it, see what we can learn from it, and then do some wrangling as well so we get in the right shape. All right, so we're going to be using these packages here. It is possible, I don't remember now if I asked you to install the tidyverse package. It is possible you don't have that installed yet. If you don't, we can just go ahead and do the install. So install.packages, have that in quotation marks and say tidyverse. If you run that, just this line of, so if you just run this line of code here, it's going to install it. And if you recall, we just install things once. So, if I just run this, it's going to install on my side. It may take a little, like a moment here, just because tidyverse. So here is asking me, do you want to install from sources? I'm going to say, I'm just going to type yes and hit return. Okay, so in my case, I actually typed yes twice, so it gave me an error. So I'm gonna run again, install.packages. It's gonna ask me again if I want to install from source. I'm gonna type yes here on my console and hit return. And it's gonna move along. So if it asks you that, you can just go ahead and say yes and let it install things. And again, just a reminder that what the tidyverse is a collection of package. Yes.
Constant error object type. It's not-
Okay, did you have tidyverse within quotation marks? Yeah, maybe that could be it.
I think I'm unable to install the dlocker package. And when I'm trying to do that, it is suggesting me that a version of this package for your version of R might be available elsewhere.
Okay, let's look into that as well. So tidyverse is still installing. There's a lot of packages within tidyverse, so it's just going through that. I'm assuming it's also going through that on your side, so we can just wait for that to go through, but yeah, at least I'm gonna have to wait for it to complete before the console becomes available for me to look at it or to do something new. So let's just wait for tidyverse to go through, and then we'll look into the dlooker package. But that's also one that we're going to be installing here, and that just helps us to do some data exploration here, trying to understand the structure of the data, especially on this type of data that you're going to see in a second. It has a lot of information and a lot of columns that can be kind of confusing. Is it still installing for you all, or has it finished installing tidyverse? Is finished?
Yeah, that was, it's not.
Is not installing?
The dealer.
Oh, the dlooker? Okay, let me try that on my side. Okay. All right, so that's, I mean, we were just gonna use this dlooker package for this lecture here, so it's not gonna be one that we really need to use a lot. For now, let's just ignore that and not use it. I'll look into it and see if there's a way for us to get around this, but I just don't want to spend a lot of time doing this in class. So yeah, for now, just comment off that install.packages dlooker and also comment off the library dlooker that comes below it, so R doesn't try to run it. Also comment off your install.packages tidyverse. You know, especially if you're gonna do what I'm gonna show now of just going ahead and running the whole chunk by hitting the play button, you don't want to have your install.packages functions active, right? Okay, so was everyone able to install tidyverse, or did anyone have any issues that you need help with? All right. I don't hear anything, so I'm gonna keep going. So the first thing that we're gonna do is read in this data. I wanna read in and assign that data to an object called soy. So if you come here on the read underscore CSV, I'll read the left part of the code. If you remember, if we have your cursor blinking in between the quotation marks and you hit tab, it's gonna show you where you are. Again, we are inside of the code folder and there's only one file, so it already populates for you the name of that file. Go ahead and delete that. We need to go one level above, so we hit .. Now, if we hit tab, it's going to be at the main folder of this project. Go inside of data. That's where our data set is. Hit tab again. That's going to populate the soybeans_NASS.csv for us. So this data set here, it is a CSV file. That's why we're using read CSV. If you had an Excel file, it would be like a read Excel or something like that. So just to remind you of why we're using this function.
Question.
Yeah.
back at running the library packages, just above that. When I went to run the janitor package, I got it said attaching package, janitor, following objects are masked from package status. And it just gave me like two, crisp and Fisher tests.
Yeah, so that is just a warning. So it is still working, right? It's just telling you that there is. So I don't know if you guys remember that conversation we had about bringing a package that has function names that may be present in other packages. That's what happening right there. It's just telling you that janitor has some functions that share the same name with other packages, and it is masking those functions from those packages and using the janitor ones instead. And that's just a warning. I mean, just, for your information, but we don't have to worry about that.
Thank you.
Okay, so please go ahead and breathe in the soy data or the soy object. There are some messages below it, but that's fine. We just want to make sure that, that object pops up on your environment. You can see that. And here's just basically saying us how it was treating a few of those different columns. So so if you were able to bring it in, and it is on your environment, we need to start from that point. If you were not able to read it in for some reason, let me know, because we need to work on that before we move on. All right, so let's get started with looking at this data here. So the first thing that I want to do is basically just print it. So I already left you, if you remember, if you just use the object name and you run it, it will print right below for you. So what we notice here, just by quickly printing it, is that this data set has 6,413 rows. So there's a lot of data here, and it has 21 columns, right? And these columns are, you can just browse by going to the right on this arrow here. There's a lot of them. The only one that actually has the true, remember, this is production, right? So soybeans production in counties in Georgia. So the column that has the actual production data is called value, and then everything else is just characterizing what this is. So, saying soybeans production measured in bushels, and there's a whole bunch of columns that are specifying what that is. Also, two other important columns are the county name, because that's going to really helps us to put this in a map, and the year as well, which is in the first column here. I don't know if you can already if you're already thinking about this, but there's a lot of things that we have to do with this data set for it to be useful for us. I always encourage you to run a summary function and also look at that, just again to have some understanding of some of the variables. So we have their titles here, and then pretty much all of them, if you notice, or maybe most of them are actually being considered a character, including, so year is not a character here, but if you look at value, which is our actual value of production in bushels, it is being considered a character. And that's something we're going to have to fix before we actually make sense of this data. Okay, so this next chunk here would be using a function from the dlooker package. So we're going to just skip that because we don't have that package installed. But I do want to, so one of the things here is that it has one of the columns is called program. And if you remember, we could get data from either census or survey. Census, I think, is every 4 to 5 years, and survey is every year. And so this was one of the things I wanted to show you using that dlooker package, because it just shows us what are the different levels under each column. Because we don't have that, there's another way that we can do this. So if you come on this chunk below here that I started off with soy, and you use a pipe, so we're going to give a pipe and give a function after it. In dplyr, so the package we use for wrangling, there's a function called distinct. And distinct is going to basically look at a column and give you each unique value under that column. So if we do distinct on that program column, so this is how that column is called, just want to show it here with a capital P. If we do distinct on program, we're gonna see that it has census and survey data there. So what happens is the survey data has data every year. The census data only has data every 4 years. So every 4 years, you're gonna have a production value coming from census and coming from survey. And that's something that, you know, it's just something we're gonna have to deal with and make a decision on how we want to use these ones. I think we should only filter this column to contain the survey data and kind of ignore the census one since it is less frequent. That would be one way that we could handle this. And also, you know, we're not gonna go through or really talk much about all the columns that are here. But some of them may be important if you're doing something else, if you're using this data for something else. So, you know, if you are ever using NASS data, you're always gonna get all these 21 columns, maybe more. So I do encourage you to look into what they are, what they mean for your purpose. And I'm leaving you here a link for a glossary of what these columns actually mean, in case you're interested. All right, so next thing here is we're gonna go through a data wrangling pipe workflow to get this data cleaned. So in the end, my goal is to have a column with the county names, a column with year, column with really just the production in bushels per acre. Maybe we can even transform that to another metric. I left kind of those steps, at least my intention of those steps, as comments here, and we're going to be following these steps under these columns. I will ask you to help me out here based on what you already learned from previous class on data wrangling. What you think, how do you think we can implement these right here? So if you come on this chunk, notice how now I'm creating a new object called soy_w. That is my personal convention to just say that this object is the clean wrangled version of my data. If I go and just run what's in there, I'm just applying that clean names function from the generator package just to standardize the column headings, right? So just to make it easier for me as well and you to refer to them in this case here. If you just run that, you know, apply the clean names. Make sure now you add a pipe after clean names. And let's come below this comment here saying keeping only survey data. How do you think we can do that? If I just want to keep, so the column is called program and it has survey and census data. How can I only keep the survey data from using that column information? Which function would you use here? Say that again. So select is a good guess, but it's not the right one. So select works on columns, right? So if I want to select specific columns, I would use select. Filter, yes, filter, right? So let's go ahead and type filter. The current name of the column. So just to remind you, we just ran clean names on soy, right? So clean names made that column that before it was uppercase P program, now it's just undercase. So program equal sign, it's a Boolean operation, and I want to say equals to survey. And survey is all uppercase. That's because how it's coming from the data itself, right? So if I just run soy W, and you just quickly take a look at program, census, and survey are uppercase. So that's why I'm saying survey uppercase. Okay, so soy has 6,413 rows. If you apply this filter here and you print soy W, now it has like 5,877 rows. So we did leave some rows behind, right? Because we left all the census data behind. We're just keeping the survey data at this point. Okay, so now, you know, because we have 21 columns here and most of them we're really not going to use. It's not going to be necessary for us. So I just want to decrease that clutter of too many columns that are not important on the next step.
Yeah.
Yes, go ahead.
I got an error down here in Tifton.
Okay.
I
What,
did.
You gotta put quotation marks on the survey. And then put it in parentheses.
Okay, my bad. I see what I did.
awesome. Was that, did you use the quotation marks?
Yes.
Yep. Awesome. All right, okay, so we just applied that filter, just keep the survey. Now remember, we're using a pipe workflow where we're just gonna add another pipe here and go to the line below. So I want to select just the columns that we're actually gonna be using here. And I'll tell you what those are in a second, but before we actually do that, I wanna ask someone else if you can help me here with what function we're gonna be using to select a few columns. Select, right? Yeah, so select is, yeah, I guess that, I'm kind of helping you all with how I'm making my comments, but yeah, we're gonna use the select function. And remember, this needs to come from dplyr, so I think it's a good practice to just say dplyr : select. So the ones I want to keep here really are, so year is going to be important for us because that's going to determine the year of production. Since we had, I don't know, 40 years, I think, or something like that. We're going to see that in a second here. I also want to keep county, as that gives us the county information. So even though right now county is just being referred to as a name, but we're going to see in the next script how to actually use that information and make it as spatial data and turn that county name into an actual county shapefile or vector file, and make maps with it. So Erie County, and then lastly, there is a column called value. That's the column that has the actual production in, I think it's million bushels, or just bushels, sorry. Just so the value column is just bushels. I could just say value like this, but I do want to show you a quick trick, I guess, that we can do with select. So while you are selecting the county or the variable names, we can also kind of rename them on the fly. So a column called value is very much so not informative of what it contains, right? It is, all I know by that name is that it is a number, or that should be a number. So I want to rename this to prod underscore BU for production in bushels. And I could use another function to do just that, but I can also do that within the select function. So I just say here, before the value column, I say prod underscore BU equals to value. So this is going to select the value function and at the same time rename it to production underscore or to prod underscore bushels. If you go ahead and run this, and now you print it. So this is the stage we're at. So right now on select, we did not change the number of rows, right? So we apply the clean names to make the names more standardized. We only kept the survey data with the filter function, and we selected only the columns we need, which are year, county, and value, and then we rename value to prod underscore bushels on the fly with the select function. This is what we get. Okay, so one issue that you're gonna see here is really production underscore bushels should be a numerical variable, right? This should be a number. And right now, R is seeing that as a character column, and we can see that because of the CHR under that prod underscore bushels. The reason why this is happening is a couple of reasons. So one of them, the way this data comes from NASS is they add the comma as to separate the three digits, right? And a comma in any programming language means a character. So if you have a column that has a character value in even just one of its cells, that programming language is going to think that that is a character column, when maybe it's not in this case. Also, there are other cases. Let me see if I can just quickly browse here to show you. Let me do a quick filter here just to see if I can find something to show you. Okay, that's actually the data that we downloaded last year. There were some values under this this prod underscore bushels that had a value of like this, of like, it was a parentheses, uppercase D parentheses. And the reason for that is how NASS codes data that is not available. So let's say if a given county in Georgia either does not produce soybeans at all, or maybe produces very little soybeans, there's no data for that county. So the way that NASS tells you there's no data was by using this notation of using this D notation here. I don't see that anymore after we filter by survey. So maybe that's not an issue anymore this year. So we don't have to worry about that. But that was an issue last year. So we just had to replace then any D values with NAs. If that would have been the case, I guess it's not the case anymore. Yeah, so basically we can just, I guess, skip this one step here. And the next immediate step then is, so if you come back to the select, add a pipe, we can come on this comment here saying removing the comma from production underscore bushels. So we need to remove that because R is not understanding that that's a number because it has a character and that character is the comma. For us to be able to transform this column into numerical, we first have to remove that character that is a comma from all values. To do that, we're gonna first, so we're gonna use a function called mutate. We're using mutate because we are basically creating a new column. In this case here, we're actually overriding the same prod underscore bushel column. So we can say mutate prod underscore BU, say equal sign. Now there is a full package that helps you with character and string manipulations in R. So basically manipulating words and patterns and things of that sort. That package is part of tidyverse and is called forcats. One of the functions in that package that we're going to be using here is str underscore remove. So str is, oh, sorry, it's not forcat, it's string-r package. So it's str is short for string. So we're basically going to say what column there is this string that we want to remove. So that column is prod underscore bu. And then we're going to say what's the pattern or what is the character we want to remove from that column. So here we open and close quotation marks, and then you give it the pattern that we're trying to remove, which is that comma. So if you do this and you print soy W, you would see now, you know what? It didn't work for all of them, which is kind of weird. Not sure why that one is still there. Interesting.
I have another one like that too. The first one is just on like the, I guess it's just a million one.
So the first one, the other counties one, is that what you're saying? Interesting. I'm not sure. So it seems like for some reason it's coming from that other counties, and it may be, yeah, I don't know why it would do that. My only guess is that maybe what NASS does is whenever it has, like, it has counties that do report in a data, in this case production, but it's such a small amount, they kind of ignore that and combine those counties into this class called other counties. So we don't even know what's in that other counties. Let me do a quick on the fly check here. So I want to filter I'm going to use a function called grapple. This is not part of the plan exercise. I'm just kind of troubleshooting what's going on here to understand. Where we say, what is the pattern we're looking for? So there's a comma and what's the column name? So just doing this, so it returns to me only the rows that still have the comma. So seems like they're all other counties. Well, I mean, there are some actual counties that do have that problem. Okay, so I'm not sure why this is going on. My guess is that maybe the str remove only look for this once. So maybe in rows where there were two commas, it removed just one of them and not the second one. Maybe that's the reason. I don't really know how to fix that within the function, but what I'm going to attempt to do is just run this again. Because if that is the case, then if you run a second time, it's going to remove both of them. It's kind of an interesting. Yeah, I think that solved it. Which is interesting. I don't remember this happening last year. Maybe there's some difference in the function behavior. But basically, yeah, okay, so it's kind of cool because, I think this also gives us the opportunity to see, how to think through of solving some of these issues. So we applied that str remove the first time and it just removed one comma. I just basically copied that and pasted after adding a pipe, so we would do that twice, and now we removed all of them. So now we should be good. Maybe there is a way within this function str remove that you can say like remove all of them or just once. I'm going to use a quick help here on this function and see if I can learn something very quickly here. Okay, yeah, so I think this is what probably changed. I think the version of the package I was using last year did not have this str remove all function. So maybe that's what we would have used to remove all of the instances of a comma and not just the first one. Let me just try that very quickly here and see if that solves it. Yeah, so that solved it. So I think that would be a more elegant approach to do this, but our main sort of like, force approach to just run the function twice with str remove also worked. So you can either just leave the str remove all like I just did there, or if you want to keep both of the str removes following each other, you can also do that. I'm going to keep the remove all since maybe that's the more foolproof method to do this. Okay, so if I print this and I run this so you can see it, even though we don't have commas anymore, but that basically just remove the commas, but the column is still being interpreted as character. We're going to have to change that, and we're going to do that in the next step. So if you add a pipe there after that mutate on the using the str remove all, go to the next comment here. We're transforming production in bushels from character to numeric. We're going to start that with a mutate function again. The next column we're going to be, or the name of the column we're going to be creating is prod underscore MIBU for million bushels. Or let's see here. Yeah, so we're going from bushels to million bushels here, just to keep the numbers more, easier to work with, I guess, because if you have bushels, they're going to be very large numbers. So transforming that to million bushels is going to help us to just have a little bit smaller numbers, especially helpful when we're going to be plotting these. So basically, this is just prod underscore BU divided by a million, right? So a million is a number one followed by 1, 2, 3, 4, 5, 6 zeros. So a number one followed by 1, 2, 3, 4, 5, 6 zeros. That's how we would do that transformation. Oh, hold on. My bad. I'm kind of looking at the sheet and I'm kind of getting you on the wrong step. We're still going to be doing this transformation, but in this immediate next step, we need to first transform that to numeric. So if you just copy that, what we just did, and paste under that last comment, that's our last step of actually transforming to a million bushels. And just comment that off for now, so it's not active, so it's not going to interfere with what we do above. So transforming this, which right now is character to numeric, we're also using a mutate. We're also going to call this prod underscore BU. And there's a function that's called as.numeric. So we say as numeric, and again, production or prod underscore BU. So we're just saying that take this prod BU column, treat that as a numeric column, and then assign that back to the same name, prod underscore BU. So if you run this and you print it, now your production in bushels should be saying DBL for double. So now it is a numerical variable, and this is really what we need to be able to use this column for really anything else any plots or analysis that we do from this point on. And then at this point, that's when we're gonna transform from bushels to million bushels. So just add a pipe there. And then if you had already typed the code and commented that off, just go ahead and then comment it. So we have that prod underscore million bushels with that formula right there. If we run that, this is what it should be looking like at this point. So we have year as a double column, county as a character, that's okay for now. Production in bushels and as a numerical column, DBL double, and production in million bushels as well, also as a double column. All right, was everyone able to get to this point? Or maybe if you were not able to get to this point, let me know.
I just wanted to ask a question. I am able to go to the point, but the way you are writing codes, like as numeric or string removal, we have to learn all this by experience, right? Like that's how we get to know.
Yeah, so here we're really I'm just exposing you to some of the most common ones. But yeah, as you start applying this to your own projects and research, you're gonna try some, at least, you know like what functions you need to use for what steps. But of course, you're gonna have to adapt this to your own situation as you start working with your data.
Okay, thanks.
Yeah. All right. So let's do another round of exploratory data analysis. So now we already have production, we have year, we have the county names. Let's just explore this data a little bit more and understand how production is behaving over time, different counties, and just even in general. So one way that we can do that, I already left you some code here. So we're starting a ggplot. If you remember, we start a ggplot, we give it a data set name, in this case, the soy underscore W, and then we use the astatics function to set our X and Y axis variables, and also any other color or fill or shape or things like that. If you just run this piece of code, it's basically not gonna have anything in it because we have not asked for a geom yet. A very, very popular geom to explore the data distribution, which is what I want to see here, is how has production in million bushels in Georgia from the last how many years there is in this data set? How is that distributed? Like, what's the minimum, what's the mean, what's the maximum? We can get that through statistical summaries, but I do want to plot that as well. So a really useful approach for that is if you just add a plus here, hit return, we're going to use geom underscore density. So this creates a density plot for us, and this is how that looks like. So we can kind of think of a density plot as just the outline of a histogram. So if we had asked for a histogram, it would be a very similar shape, but it would be bars. A density plot is almost like the outline of a histogram. And this is what we're seeing here. So, we can really see that in million bushels for all counties and all years in this data set, it seems like the maximum production here, or the most frequent value, is probably around, I don't know, 0.1 perhaps. That's the peak of the distribution on the x-axis. And then we have, decreasing values after that point for a maximum of probably about 4.5 million bushels in a given county in a given year. So this is not state level, it's county level, and each data point is for a different county, a different year. So at a county level, we see that, the production of soybeans in Georgia for the last 40 years the maximum has been 4.5 million bushels at one of those counties in one of those years. Right, so if we just look at this and just kind of eyeball it, we see that most of the production is distributed here, even including zero, so lots of counties producing no soybeans, but probably until 0.5 million bushels in a given year for a given county. That's probably the range of where most of this data is, but then we have some outliers that go all the way to 4.5. All right, so what if, and this is, again, we just have production, million bushels in the x-axis, and the density here is just how many points there is within each one of those values. This is not telling us anything about year or county yet. So let's further explore this data set by exploring those pieces of information. So the next one here that I want to propose is that we do a plot of production distribution by year. So we're gonna start off here with a ggplot, as we're gonna be making a plot for that. The data is the soy_w, the one that we just we're gonna be using today. So if I want to make a plot where I want to have production on the y-axis and then year on the year on the x-axis, right? So I look at that evolution of production over time. We need to say here x equals to year, y equals to prod_million bushels. And I do want to look at this distribution using a box plot. So let's just get to the end of this ggplot call, add a plus, and then add a geom_box plot. Okay, this is probably what you are seeing on your side. Now let me tell you what's going on here. So year is a numerical variable. And because of that, the way that R interprets it is it gives you one huge box plot for all the data instead of giving one for each individual year. There are a few different ways to overcome this, and I want to show you one that's the easiest here, which is if you come back to your code, you go on the AES, add a comma, and in here there's an argument for group. So we say group equals to year. So now even though year is numerical, but it's gonna force it to give you a box plot for each one of the years. So if you run that, this is what we see. Right, so now we do have a box plot for each one of the years. All the points we're seeing are basically outliers in the sense that maybe just a single county that year produced that much. But really the main data distribution in the box plot happens in the box plot. So this would be, maybe this is a good example here where you would see the whole box plot distribution. And the black line in the middle is the median. So let's say for this given year here, I'm not sure even what year that is, but the median soybean production in million bushels for a county in Georgia was just below, I don't know, 0.8 maybe, right? But then, of course, we do have these points here that are outliers in relation to the whole state in this case. So we see that like in 2023, we had one county that produced like, 4 point something million bushels, whereas the state average was like 0.1, let's say. Right, so this just gives us a little bit more information about how is the distribution of the data changing over time. If we go all the way, if we just explore more of this just visually, it seems like in the early 19th, so this is actually 60 years of data. So really going back in time a lot. We can see that around 1960s, Georgia was really not a major soybean producer. I mean, there was really no counties that were above, 0.5 million bushels in a given year. And then as time progressed, there was more production, probably because there was more planted area, maybe higher yields as well, but planted area is the main driver here. So we see that maybe around 1980s, that was the peak of when Georgia was producing more soybeans and then kind of declined again. And it seemed to be fluctuating ever since. So this just gives us this idea of how is the county data changing over time using some box plots.
Question
Yes.
with that, I know each point is a county and you can see the distribution across the state with that, but with that, I think those few points that are up there like above 4 million bushels, I would imagine that's the one that's like the other counties, like it's all the combined counties together. So if we were looking at a data set with this, would we excuse that as an outlier, being that that's not one sole county, but instead that's multiple counties combined together?
That is a really, really great point here. And so as we're exploring this data, we're gonna get to that point a little bit down the code here. But we can talk about this in this point. So so that was Clint, right?
Yes, sir.
What Clint is saying is that there's a good chance that these very high production values here are coming from that other counties category. If you remember, I mean, on the USDA NASS website, they do explain, like, if a county produces less than X amount, then it gets combined into this category of other counties. So imagine in Georgia, we have, I don't know, 159 counties. Does that sound right, Doug? So we have lots of counties, right? And maybe a lot of them are being pulled into this one category of other counties, and that's what's causing those really high productions at the county level. And the question being, how do we handle that, is a really good one. And I think, it's nice to be thinking about this, because we're going to be thinking in this case specifically for this data set, but whenever you have your data, you're going to come into problems where you have outliers like this, and you need to think, what do I do with this? Should I remove it? Do I have a good reason to remove it? It will definitely affect models if you're trying to run some models. We're not going to be doing that in this part of the class, but that's a really valid question, especially for research. In this case here, it will kind of come back to your. So first off, is this outlier because it's like it was a mistake in the data collection or data entry side? Probably not, right? So it's not a mistake that someone did that this data was so high. It is actually high. The reason for it is because combining multiple counties, right? So we know, so we cannot just say, let's remove it because it's a data entry error or some type of error. No, it's not an error here. So maybe let's think more deeply about this. So it is combining multiple counties. Now, if your goal is to, let's say at some point with this data, let's say that you want to calculate the total production of soybeans in Georgia on an year basis, okay? So kind of think about the sentence. Total production of soybeans for a given year. Yeah, I guess that's the query that we'll be thinking. In that case, you do need to incorporate that other counties there, right? Because that other counties, as you can see, is producing a lot. And if we just ignore that, then we're not going to really know what was that total production in Georgia, because we're ignoring a lot of counties that were bundled within the other counties category. Now, one issue that we will run into, and we're going to have to deal with it, is how do I, so we're going to make maps, right? So plots, we're looking at plots right now. We're actually in the next script to be making maps with this data that we want to show those counties in the map and give a color according to production. When we get to that point, we're going to have to think about how do we handle the other counties, because I don't even know which counties those are. I have no idea. It doesn't tell me. So we're going to have to drop that information to make maps and basically ignore that, because there's no county that I can assign that value and make a map with it. So I guess, it kind of depends on your objective and also how you judge that data. This is how I would approach this, is first looking at, is this a data entry typo or error of some sort? If yes, then you can remove it because it's not a valid data point. But in this case here, it is a valid data point. It's just not one that we have all the information to make sense of. Does that make sense?
Yes, sir.
Yeah, and does anyone else have any thoughts about that? Because maybe you all have a different approach or different thinking.
Not with respect to that, but I had to ask one thing. Can you kindly explain this code? Because I was unable to understand that. Up to that point, I'm unable to learn what this code is doing. But like the one that you have wrote out 100 number and 101, I'm unable to understand that. So please explain it to me.
Yeah, so we're using a ggplot function to start a plot. We always do that with ggplots. The first argument is the data set coming in, And then we have this AES function that stands for aesthetics, where we are defining how this plot looks. So here's where we say what's the x-axis, what's the y-axis. And in this case here, we need to give it specific groups based on year, because otherwise it just gives one big box plot. So after we define how the plot looks in terms of the axes and colors and shapes, then we add a plus, and then we ask it to add a geometry. In this case, we're asking for the geometry of box plots. So that's what the code is.
Okay, with respect, the one that you wrote it earlier, from which you have modified it, like it gave in just one line, the entire data. No, the lower code. When you wrote this in earlier, the entire data was along one axis, one line. Why was it like that, and how and what came in your mind to, separate those? I mean, that's what I'm asking for.
Okay, so you're asking about when this happened? Yeah, so so because year is a numerical variable, if you ask for a box plot of a numerical variable, R is gonna combine all the data and give you one box plot, which is happening here. There are a couple of ways of fixing this, where one of them, at least on the visual side, so the ggplot is just plotting, right? We're not changing the data itself, we're just changing the way the data appears in a plot. So then we just add that group variable there, so it forces ggplot to group data from a given year in one box plot and give you just that instead of giving like a huge box plot for the whole data set.
Okay,
Does that make
thank
sense?
you. Yeah.
Yeah.
Thanks.
And this, as you all gonna see, these things is something that we're gonna be going through some things in class that you're gonna learn, but really you're gonna run into issues when you do this on your side for sure. And then it's just a matter of, Googling it. Like Google and ChatGPT are gonna be really helpful to learn
Okay.
how to fix those things. Yeah. All right, so let me run this again with the group by year, or the group with the box plot per years, as we were seeing. So this just gives us that distribution over time as well. Okay, so the next piece of code here, I left you most of it, where I want to plot the production distribution by year and county. So if you come on that piece of code, I already left you most of it there. So we're starting, so if you think about it, a given county appears only once every year, right? You're not gonna have the same county twice in a year, because that's not how the data was collected. So if we use, it doesn't make sense to use a box plot, because a box plot needs multiple points to give you their distribution. So now what I wanna do next here is to create, for each county in this data set, to create a line that connects all the production points of that county over time. I already left you the code here, or part of it. So we're starting with soy W. We have year on the x-axis, production on the y-axis, and I want to color those lines based on county. So each county is going to have their own color. Now, if I do want to add a line here, what would you add to this code? So let's add a plus, hit return. We have to add a geometry here. What geometry would you add here? If, again, I want to show a line plot by count. Neva, what do you think? So imagine now I want to have, like, for each county that has production data over time, I want to draw a line for all those points for each county, right, on this map. Geom line? Yeah, I agree with that. So let's try geom line. And don't run this yet, because we have 159. Well, let me run on my side first and see if that. So you can see what it looks like if we just run this like this. Because we do have 159 counties, then and we're given a color to each one of them, it means that our legend has 159 entries, which make our plot very difficult to make sense of, as you can see. to avoid or to keep the legend from appearing, we can come inside a geom line and say show.legend. So it has this argument called show.legend and set that to false. So if we run that, then this is what we see. Even though we're not sure which county those are, but I think at least it gives us, again, that visual idea of how individual counties' productions were changing over time. So in this case, each line is a county. We see again here that there is this this line here that is probably, I mean, it could very easily be that other combined counties, this orange line here, I guess at this point we don't know yet. But we have, some feeling of what's going on. Again, we see that probably between, around 1980s was the golden age for soybeans in Georgia as far as production, and that kind of fell down. And maybe a few counties here picked up more recently. But it's as you probably know, and if you don't know this, I'm gonna tell you right now, soybeans is not a major row crop in Georgia, right? So that's why we're seeing these declines. If we were looking at cotton, peanuts, those would be the major ones that would be producing, have a large planted area, large production, and so on. But this is kind of messy and kind of difficult to really make sense of, right? Because each county is a line here, so it gives us some idea, but it's still not super informative as far as knowing what was the county that was producing a lot and so on, what was going on. Okay, so we explored with using some graphs, right? So that's, I hope that you got some ideas of how you can look at your own data, especially if you have time data on the y-axis, that's normally where that would go. But now let's just do some tables here, or explore this data with some tables that's going to be more useful to extract the information and really know which counties and what year things were happening. Okay, so here's a question that I want your help with to come up with the code of the next chunk. What was the highest production record of any county across all years? And when did it happen and which county reported it? So let's just first focus on this question here. If I want to know what was the highest production record of any county at any given year. So really just want to know what was the highest production in this data set. If we start with the soy W, right, I just want to start there and just print it for you so you get a reminder of the column names. How would you, can anyone help me here to think of, like, how could you use some of the functions that we already used to retrieve the maximum value of production in Georgia in a given county?
Can you filter out the other counties somehow?
Okay, I like where you're going. So Doug said, maybe can we filter a given county, right? To know what was the maximum value. This is definitely one of the ways that we can do it, and I do want to show you that. So I think I'm gonna, well, let's just think in words first. So we would filter, it would be the filter function. But how would you create this condition of filtering? What are we looking for? Ujwal, what do you think?
The maximum production.
Yeah, okay, so Ujwal said the maximum production. That's the right way to go. I will show you one way here. There's maybe a few different ways of doing this, of answering this question. I want to show you one of them because I think it's useful for you to be exposed to it. So if I want to know the highest production is under this prod underscore million bushels column. So I can say I want to filter the production million bushel values that are equal to the maximum production million bushel values. So this is basically looking at this production million bushel column and returning to you only the row that is equal to the maximum value of that column. So if we do this, this is what we get. Right, so it basically just gave us one value. And again, as Quinn was saying, that the possibility of that high production coming from that other counties, this is what we're seeing here, right? So we're seeing that other counties, in this case, it was the highest production coming from that category in 2021. So really, that is the highest production. It's not the most informative one because we don't even know which counties those are, but at least we know it happened in 2021. So there is another way that we can do this. I want to show you to give you an alternative that would be a little bit more information for you. So in this case, it's just giving us the data row that had the highest production, right? Now, let's say if I wanted to see what were the top 5 highest productions. I'm going to comment off this filter here, and I want to give you another function. So one way we could do this, and is actually even simpler than the method of thinking about the filter function, is just to arrange. So if I arrange the column production _ million bushels, it's just gonna sort it. The default behavior is to sort it in a ascending order. If I want on a descending order, I just add that desk function here and run it. And then we can see what, like from the highest to the lowest, what that was. Of course, my question here is what was the highest? And really the highest individual county was Burke County. That if you haven't heard of Burke County, that's a very important county for row crop ag production here in Georgia. Burke County is among one of the main counties, both for corn, soybeans, maybe not peanuts as much, but they have some peanuts, but also cotton is one of the main counties in the state. So we see here that, sorry about that, the noise here coming, someone is clipping grass right outside the room. But we see that Burke County in 1979 had the highest production that a county ever had in Georgia in a given year was Burke County in 1979. Right, and then we see that those other counties combined are also popping up, but that's really not very useful for us because we don't know which counties those are. Okay, so what if now I want to know the lowest production? So pretty much just the same thoughts, right? Instead of highest, I want to know the lowest. So we could do the same here, the filter. So if you just copy that, I guess we can just copy that whole chunk and just paste below here. So we could, one of the ways would be removing that descending order one, right? And just having on a ascending order, which then is going to have the lowest one first. And again, this is going to be, looking at this way is going to be useful because if my question is what was the lowest producing county in Georgia historically, the answer would be Glasscock in 1959, right? Because everything else is other counties combined, and that is not a single county. So that's how we could explore that. If you think about it, you could have also used the filter if you were to use that approach. You would have just, instead of using the maximum, you would have used the minimum, which in this case, it would be the first entry for other counties combined. Right? So, if we just go back, I'm just gonna comment this off and uncomment the arrange so we can see that Glasgow County. They just have a comment here because the production of this county was in, the lowest county level production a given year that we're seeing here of 495 bushels. It's a really, really small production, right? So if you just think of it, if you had an average yield of 50 bushels per acre, which is not even that high for soybeans, they only would have needed one field of 10 acres to make this cutoff, to be in this data set, So it's really not, not very impressive from Glasgow County in 1959. Okay, so another thing that I want to learn about this data set. So remember, this data set has almost 6,000 rows, right? It's a lot of data, and we can ask so many different questions from this data set. And I'm asking you some questions here and kind of walking through with you and seeing how we can answer them. So the next question I have here is, I want to plot the average county production for each year, okay? What I want you to be thinking of is the data set we have now does not have the average, right? We have all the values here. So if I wanna make a plot with the average county production, I will need to do something before I get to ggplot, right? I have to first calculate that average. And I hope in your mind you're already thinking about this, how to do this. So if we're starting off with soy W, what do I need next? So let's add a pipe and hit return. What do I need next here? What would be the immediate next function in this flow to start answering this question? Let me ask someone online, maybe. Kumar, what do you think?
I cannot think of right now. I might need some more time.
Okay, no problem.
Yeah.
Rolando, what do you think? You're muted.
I said, no ideas coming to my head right now.
Okay, no problem. And this is why we're doing this exercise, because I do want you all to start thinking about this, and it will click eventually. And when it click, that's when you're going to be using this. And I hope you're going to find this useful for not just the class, but for your own data as well. Let me ask maybe, so in Tifton, we have Clint and Dalton. Is that right? Yeah. Hey, Dalton, what do you think?
Well, I try to run just the mean function at first before grouping it, but it says argument is not numeric or logical.
Okay, so what was the function that you tried to use right here?
Mean,
Mean, okay. So that, we're gonna use that, but before we get to that point, we have to do a couple of other steps. Which one? What do you- Yes, go ahead.
We first might have to group them by county.
Yes. Yes,
Yeah.
that's the first step, right? Because I want the average by county. So I have to group by county first. Yes. Thanks, Kumar. So let's do a group by, the column name is county, as you can see there. So, oops, county. So we add a pipe. And then, do you recall that group bys normally don't work together? They need another function to do what you want to do with that group. Eva, what do we need here?
County and average all year.
Yes, but what function do we need to do that here? Do you remember? No. Sundays, do you seem like you remember? Do you know? No? Doug, what do you think? Brunelisa, what do you think? Which function do you think we need here? Yeah, I mean, that's not the exact function yet. Okay, let me help you out here. So if you remember, group by sets the grouping. And now to calculate the average, if you recall in the data wrangling exercise you did exactly the same step. So in that exercise, you call the function summarize. So the function summarize is where you're gonna ask some summary of this group, right? It could be the mean, but it doesn't have to be the mean. It could be the minimum, the maximum, the median, standard deviation, anything like that. So we need to give a name to this column first. And I want to name it, let me see, what was my, just so I follow my script here. So I was calling this mean prod. So mean production, that's the name I was giving it. I want to give it an equal sign, and we're just gonna have to say So we want the mean, right? So I use the function mean here on that, on which column? Which column would you put inside of that mean function?
Production per million bushel.
Yes, production, right? And we want the million bushels because we're working with that. Yeah, so we want the mean of the production in million bushels, right? So if we run this, now we end up with 157 rows. Georgia has 159 counties. So if this name was greater than 159, then maybe we should look more into it and see what's going on. It could be a little bit higher because we have those other counties categories, but it shouldn't be like 200. That would be a little bit too much. And then we end up with these two columns, right? So the county name, because that's the grouping we're doing based on county. So it's keeping county, and then it's calculating the mean of production for each one of the county. So if you think about it, what it's doing here is averaging over years, right? It's taking all the years for a given county, taking the average of that and giving you that number on this column here. Okay, so we did this very quick wrangling here. We're ready to plot. So we can add a pipe here and start a ggplot call right off the bat, right there. So we're gonna say ggplot. Because the data is coming through the pipe, we don't have to specify the data name here because, I mean, there's not even an object that where this result is saved, so it wouldn't even be able to do that. Of course, you could save this to an object and call that object name, but we're not doing that here. We're using pipes. So I'm gonna say AES, go straight into the AES. I wanna have, on the x-axis, I wanna have county. On the y-axis, I want to have mean prod. You know what? I just noticed actually that I ask you a question and I'm answering a different one. We can go ahead and run this just to see, because I think there's even another. I think there's another chunk where we look at this. My question was actually production for each year and not each county. So sorry about my own confusion here. Really, the only thing, we can go ahead and change that, because really the only thing we would change here is our group by, instead of being county, it would be, well, okay, plot the average county production for each year. I'm just thinking about my question again and making sure I'm providing you the right answer. So if we want the average county production for each year, but without specifying a county, but just the year, yeah, so we would come on the group by. I'm sorry for my confusion here, but we basically just changed the group by for year, which then at the end, instead of having a column called county, we have a column called year, and then we can plot year on the x-axis instead of county. Yeah, so this would be the, I guess the code to answer the question I had above. The quote I had before was to answer the county production average and not the year average. So if we come here and we can just add a plus and do a geom line. Let's say I want to connect the year averages across time. I can just come here and add a geom line to this. And this would be the average production at the county level. Remember, this is not state level, right? This is how much each county produced on average for each one of the years, and we're connecting those points over time then. So I guess, this may be a little bit easier way to look at that overall trend that Georgia had a lot of, or the mean production at the county level over time was higher at 1980s, and then it went down, it went up again, and then it's kind of fluctuating around 0.3. Between 0.3 and 0.2 in the last maybe 10 years or so. Yes. Yeah, so, and so what a couple of things to notice here that maybe was it the first time we saw is within a pipe, like data wrangling pipe workflow, we use the pipes. But once we get into ggplot, we use a plus. So just to remind you of that, there's that difference in syntax. Yes, Rolando.
Yeah, I got, so plot the average county production for each year. You said this is county, not state, right? But what the message you type in here is the average of the whole county in the state of Georgia, uh, average for each year.
That's right.
Is that correct?
That's correct. Yep. Yeah, and
So, go ahead.
please go ahead.
No, I was just, I thought it was, you took in a specific county and you summarize all the average for each year. That would be a lot more data for each county. If you wanna say, okay, Cobb County production for bushels in 2050 to 2022, I will give you a lot of data just for that county. Not, so I guess it's for the whole counties, 159 counties in the state of Georgia,
Yeah.
that
So
medium, and then the production for the last 20 years or whatever.
yeah,
Does that make sense?
just to connect this back to a previous plot. So if we go back to this plot here, okay? So the black line on the box plot is the median. So it's not exactly like the mean. But what we are doing is basically extracting the mean of those box plots and connecting them. Whereas in this plot here, each box plot has data for a given year for all counties combined. Right? And now we're just taking that average production at the county level and taking the average within the year and providing and plotting that as a line plot. Another way of thinking of this is also on this plot here where we have each line is a county. Now imagine we're taking for each one of those years, the average of each one of those lines. Right? So if we were to plot all these lines together with this plot here, we would see that this black line would be kind of in the middle of that distribution of all the counties. Yeah, sorry, I guess the way that I worded the question got me confused about the answer, which probably got you all confused as well, and I apologize for that. But really, yeah, the question I'm asking here was if we average over county and have a mean for each one of the years, that's what I wanted to show you here, how we would do that and how we would plot that to learn from it. But you're correct. I mean, everything you said is what we're doing here, Rolando. So you're on the right track. Anyone else has any questions or issues, thoughts? I guess let me ask those of you in the class that are actually from Georgia and may actually have farming operations, as I know Doug does. Maybe I don't know if well, I don't know if Clint or Dalton are from Georgia, but if you are, and if your family's farm, have you ever grown soybeans? No, so not on Doug's farm. And what county are you from? Mitchell.
There's a couple.
Yeah, this is interesting because you could come on this data and filter that county, right? And see just that county over time and see how that behaved. But from what you're saying, seems like maybe Mitchell is not going to be one of the top ones as far as soybeans production. Clint and Dalton, are you guys from Georgia?
I'm from Wayne County and we're a consultant for a lot of farmers, and this is the first year we've grown a significant amount of soybeans. We've got like 2,000 acres of soybeans this year, and we haven't had more than 500 since or before.
Nice, nice. Yeah, I think, if we look on the economic impact of different crops in Georgia, of the four main row crops, soybeans is normally sitting at the last position, at least in the last few years here in Georgia. So not a major crop, but things change. Looking at this data here, something we learned last semester is that wheat used to be a very important crop in Georgia. I don't know how many decades ago, and then these days is really not anymore. So how those things change over time and evolve. So awesome. Thanks guys for sharing that. Okay, so the next the next thing here I want to know is what was the latest year reported? So what is the most recent year where production was reported in Georgia? You know, I mean, we kind of know this just based on the data we downloaded because it clicked all the data and it was all the way up to 2022. But some other queries from NASS is not going to be like that. So we did this exercise with some other crops, like some tree crops that we have since interested last year that really did not have data every year. So just want to show you if you wanted to be able to see this, what was the latest year reported? There's a few different ways. But let's just get here at this pipe. One way that I want to show you is we learned this function called distinct that basically tells you individual values or unique values within a column. So if I get the distinct values within year, it's just going to return to me, in this case, 64 rows, which means there are 64 years, different years in this data set. And then, you know, if I want to know what's the latest, and I guess latest may be a confusing word, maybe like what's the most recently reported and maybe we can think about that. That would be 2022, as we can see here. And if I just wanted to know what was the oldest, I guess, year reported, or the one that goes most back in time, we would have just changed this again to that desk for descending order, and we would know what was the oops. Sorry, the desk is not actually distinct. So distinct gives us the distinct values, and then we plug another pipe and we use the arrange function that then we use the descending order of year to get. No, actually it does give. Okay, there you
Yes.
go. Okay. Yeah, so it does give us that the oldest or the smallest value first, right? So that's how we would know what was the oldest data reported in this data. That's 1959. So if you think about it, it's kind of impressive that we can get this much data back in time for a crop at the county level in the US. I don't think we can get this type of data. I mean, for sure not in Brazil. And Brazil is one of the major ag producer countries as well, and we don't have this type of data. So it's really cool that USDA collects and makes this data open to the public. All right, so my next query here, what was the highest production in 2022? So the latest year we saw was 2022. What was the highest production in that year? So now I'm gonna I think this is a simpler question that I'm not confusing you. So how would you answer this question based on what we already learned? What's the first step here? Filter, okay, I like it. When Lisa said the first step is filter. So I'm just gonna print the data set so we see the column names. So we would first filter, what would you put here for Lisa? Okay, year. Equal. 2022, yes. I agree, perfect. So now we have the data frame coming out only has 19 rows, which in this case, if you think about it, if we only filter 2022 and there's only 19 rows in this data set, and one of them is other counties, so really there are only 18 counties in Georgia that reported soybean production in 2022. I guess, there are more because there are other counties under the other counties category, but we really don't know how many or which ones they are. Okay, so we filtered that. In this case here, if we want to know the highest, we could look at this and give an answer. And I just want to tell you, so there's going to be there's going to be a mini project that's going to ask you similar questions what we're doing today. So it's important that you understand what we're doing today and why to answer those questions. If I ask you what was the highest production in 2022, if the question is more clear in saying what was the county with the highest production in 2022, you should say Houston, right? You should not say other counties because we really don't know what's in there. So I just wanted to give you that heads up as we develop this. Okay, maybe we can
Don't you
start,
have to arrange it over there so you can have an order
you mean
arranged
on the previous one?
by accent? No, in the right there.
Okay,
So you
so,
say Houston is the in production Bushel is actually Lawrence County,
oh
isn't it?
yeah, that's a good,
So you have to arrange it by
yeah.
amount or average mean
Thanks,
production.
Rolando. I saw the 4.1 on top and I kind of assumed it was going from highest to lowest, but it's not, right? It is actually, yeah, I'm not sure what is arranging by, but it's not from highest to lowest. So thank you for pointing that out, and I'm glad that you caught that before I moved on. Yes, so to really know the highest production, it would do a range, right? And then do production underscore million bushels. This comes from lowest to highest, right? So within the range, that's when we use the desk for descending. So it shows us from the highest to lowest. Thanks, Rolando, for pointing that out. Yes, so in fact, it's Brooks, right? So Brooks is the highest producing county in 2022 in Georgia with 0.4 million bushels produced. So really not that much, right? All right, so let's plot production over time for the highest producing county in 2022. I hope you're starting to hear these prompts, these questions, and start thinking of what you need to do to give me this answer or to find this answer yourself. Right, so I want to know the plot, or I want to make a plot of the production over time for the highest producing county in 2022. Doug, what do you think we should do next year?
The have the Houston County for every year.
Yes. Yeah. Yeah, so Doug said, I want the Houston County for every year, right? And that's correct because sorry, not the Houston was before I arranged data set. So it's actually the Brooks County, right? So in 2022, the highest producing was Brooks. And I want to plot Brooks County over time. Ujwal, what do you think?
We need to make a plot.
Mm-hmm.
We put year in x-axis.
Okay, but so the only thing, sorry to interrupt, but the only thing is I just want to plot the highest producing county in 2022.
Or GG plot.
So if we,
We need to
First, we might need to isolate the data for that specific county, and then we can proceed with the plotting.
yes, so how would you do that, Kumar?
I guess we're gonna group by or filter by, something like that, filter by that specific county, and then do the further steps. I'm not unable to do that, but I think that's the first step.
Yeah, no, that's good. I like that you're all thinking about this because really the first step is thinking of the steps you do, and then you think of how you do that in a programming language, right? So yes, we first filter, right? So if the question is asking here, production over time, so that means I want all years, but just for the county that had the highest production in 2022. I know from the chunk above, the highest producing individual county at least was Brooks, right? So I really have to filter county to be equal to Brooks first, right? So I say filter county equals to Brooks. So now I only have Brooks over time. right? I have 62 rows of Brooks and Brooks appears once each year, right? As all of them, well, as you would expect, unless a county like produces soybeans and is appearing in the report, and then it does not produce a lot in some certain years, then it's not going to be present in those years. But I think Brooks may be present in almost every year here. And then we just plug this into a ggplot, right? So now at a pipe, we do a ggplot. I want to plot production on the y-axis. So inside of AES, I say y equals to prod underscore million bushels. And I want to plot it over time, meaning that on the x-axis is going to be year. And then I can add a geom or a plus there, and then a geom underscore line. Let me decrease a little bit the font size so you can see the code and the output. But this is how that looks like. So for Brooks, which seems like, at least in 2022, Brooks was the highest producing county in Georgia. It seems like also for Brooks, its golden days of soybeans were in the 1980s, late 70s, early 80s, where it was producing almost 1 million bushels per year. Then that decreased a lot, and then it has fluctuated in the more recent years. All right, I want to stop here because we're already over time. But before you all go, let me open the GitHub issues so we can claim your or your attendance today. Attendance January 24th. All right. I just submitted the issue, so please go ahead and claim your attendance if you are watching live. And we're going to continue this exercise. We should be able to finish next Friday. And then on Monday, we're going to continue using this data set then to make maps, to make county and state level maps of soybean production for Georgia. All right, that's all I had from my side. If you already claim your attendance, you're free to go. Let me know if you have any questions or issues. I know Rolando and I think was Dalton maybe that had an issue, or Clint that had an issue with the wrangling.
Yeah, it was Clint.
Okay, Clint. Okay, so let me do this. I'm gonna wrap things up here and go to my office, and then I'll send you guys a Zoom link for us to connect and troubleshoot things. All right.
All right.
See you guys soon, and see everyone else on Friday.